Similar to the serial data line, the serial clock line is actually also generated by the master. Uh, it's really straightforward. By looking at these particular graph, we can actually figure out how the clock looks like. Whether if you're in data 1, data 2, or data 3, you can just basically set it to higher than that. You just set it to 0. Okay, and we take a look at it. What matters is actually the frequency at which we operate. And as it turns out, that particular protocol specify a few ranges. So if you are between 0 to 1 kilohertz, you are in the standard mode, and then in the fast mode is up to 400 kilohertz, and if you go to 3.4, it's actually in high speed. Again, in today's standard, this is not really high speed, but for the peripherals that utilizes the I2C, it's actually pretty fast. How do we do this? It's really simple and straightforward. We have seen it before many times. It's actually just a timer, and that timer basically it's a modular timer that ticks at very specific times, and these times are actually specified by the divisor. And you can actually figure out how this is done. We basically take the system clock, we divide it by the sought after frequency, and we're doing 4 because I care about the quarters, because remember, it's like all these phases in here operates into quarters in here. Okay, these are quarters, that's why we divided by 4. The half is pretty straightforward. It's the same counter. You can basically take a look at the, basically ignore the least significant bit, and you will be having the halves if you want to. Just basically read these values. So maybe instead of just generating ticks, what you need to do is maybe look at the value stored in these counters instead of generating ticks. And the reason why we look at these values is because I have quarters and I have halves in here, and I have to differentiate between them. And that's really straightforward. Generating the clock is really straightforward in here.